Good afternoon, class. We are looking at pre-calculus practice test number 3, covering chapters 5, 6, 7, chapter 5, trigonometric functions, chapter 6, periodic functions. Those are the ones that we are going to look at. This is the second part. So we want to find the amplitude, period, intercepts, and phase shift of the function. Sketch the graph of a complete period. The function given is y equals -6 sine pi over 3 times x plus 4. So I'm going to give you the synopsis of what we need to know in order to graph uh, trigonometric functions in general. So first and foremost, here's a complete cycle. And of course, it continues indefinitely on both sides for a sine function. So when y is sine x, the period is 2 pi, and we want to graph it from 0 to 2 pi. It looks like that. First and foremost, you cut this into 4 pieces, 4 arcs. So this is one of them. We call it arc 1 in essence, from 0 to power 2. Here's the second part, from power 2 to pi. Here's the third part, from pi to 3 power 2. And let's see this color now. Here's the fourth. So what do? You cut the period in 4 parts, and you get 1, 2, 3, 4 arcs. So and if you use the endpoints, for example, 0, if you plug in, you get 0, 0, power 2, you get power 2, 1, and the rest of them. So 0, 0, power 2, 1, pi 0, 3 power 2, -1, 2 pi 0. This is the fastest way to graph this. And for a sine function, domain is all real numbers. This continues indefinitely on both sides. Range is from -1 to +1. Range is limited. T, the period for a basic sine function, is 2 pi radians or 360 degrees. Amplitude is only 1. Okay, so basically, the number in front of sine, the absolute value of that. So what is sitting in front of sine? Nothing. That means 1 times sine x. So the amplitude is a equals 1. So that's for the basic sine function. What happens when the function is more general, such as a sine of parentheses bx minus c plus d? First and foremost, you take the b out. So if I factor the b out, this becomes x, this becomes minus c over b. And also, I want you to see in some text, they may show it in this format. So this is a sine of b times x minus c over b plus d, or in this format, a sine omega, parentheses x minus phi over omega plus b. Depending upon the text, it makes no difference. So what you need to know, the amplitude is still 1. Okay. The period is 2 pi divided by b, or omega. Okay. And there's a phase shift of c over b or phi over omega, and up and down by d amount, whatever d or b in this case is. So the period t is 2 pi divided by the coefficient of x, b. You can say 2 pi over b or 2 pi over omega. Amplitude is absolute value of a. PS, short for phase shift. Horizontal displacement is this. If you have a negative sign, is c over b or phi over omega. If you have positive sign, it's the negative of. So you negate that, negative of that. C is less than 0 or phi is less than 0, phase shift is to the left. C is positive or phi is positive, phase shift is to the right. So let me. So we mean that. Note, The midline of a function is the horizontal line midway between the maximum and minimum value of a function. For y equals sine theta, the midline is the line y equals 0, the horizontal axis. And in general, the midline has the equation y equals this, d or p. I'm using this one, everybody. Y equals d or p. You want to pay attention to this. So the terminology midline, in case you come across it, you know what that means. Now let's actually do the work. So here's the process. We are going to find all the important aspects of this function as it was asked. So the amplitude is the absolute value of -6, and I have the synopsis of it here. So the absolute value of this number period 2 pi over omega or 2 pi over b. Notice the coefficient of x is pi over 3. So we're going to divide 2 pi by that. So 2 pi over pi over 3 means number 6. Since there is nothing next to it, we don't have any phase shift. And in other words, doesn't shift to the right or left. Phase shift or PS, none. So I'm going to look at this two different ways. So for now, we're going to ignore that. We're going to completely ignore that, and we're going to grab this, and I'll show you what happens next. We are going to cut this into 4 pieces. What are we cutting into 4 pieces? The period is number 6. Remember, 4 arcs. Let's cut this into 4 pieces. So when we divide 6 by 4, we get 6 over 4, or 3 halves. So since there is no phase shift, we start from 0 and we go to 3 halves. And then 3 halves, we add another 3 halves, becomes 3. And then 3, we add another 3 halves, 9 halves, another 3 halves becomes 6. So this is what we get. 3 halves, 0 to 3 halves. 3 halves, 2. When you add 3 halves, you get 3. 3, 2. When you add 3 halves, you get 9 halves, and so forth. The first one must be 0. The last one must be 6. Again, because the phase shift is 0. So we are going to plug in into what? Into this portion. Y equals -6 sine pi over 3x. And observe to see what we get. Starting with 0. If I put 0 here, I get sine of 0, 0 times -6 is 0. Then 1.5. If I put 1.5 instead of x, divide by 3, then I get 1/2. So it's pi over 2. Sine of pi over 2 is +1 times -6 is -6. If I put number 3, 3 and 3 cancel each other. Sine of pi is 0, -6 times that is 0. And you can figure out the rest, I hope, on your own. So 4.5 divided by 3, you get 1.5 or 3 pi over 2. Sine of 3 pi over 2 is -1 times -6 is 6. If you plug in 6, you get 2 pi. Let me show you that in case. Let's say we want to show this one. So you get, and I'm going to erase it, y equals -6 sine of pi over 3 times x 4.5. Now this becomes minus 6 sine of 3 pi over 2. And sine of 3 pi over 2 is negative 1. We get positive 6. If I put number 6 in here, 6 and 3 cancel each other. I get negative 6 sine of 6/3. That means 2 pi. Sine of 2 pi is 0 times minus 6 is 0. That's how you get that. Okay, everyone? Now let's plug in the values. 0, 0 here. 3, 0 here. 6, 0 here. First we go with easy ones. Then the other two, 1.5 and negative 6. So 1.5 and negative 6. So this is 1, this is 2. So somewhere here. And then 4.5 in between and positive 6. And you can graph this. Now this would be this function, everybody. Let me erase my work first. This is the function. But that's not what we want. We want this function. So basically, you have a vertical shift of 4. So just take this up by 4 units. So vertical shift is d equals 4 units. I'm looking at this one, okay? Vertical shift, d equals 4 units. So 4 units up. So basically, move this 4 units up, which means you use the same x coordinates, and then you add 4 to each y coordinate. This becomes a positive 4, negative 2, positive 4, 10, 4 is also called the midline. So we add those. Those are the new points. We shifted up by 4 units. This is the graph. And of course, it is asking for one complete cycle or period. Otherwise, you continue indefinitely on both sides. So this is one way to do that. I'm going to look at the same question, a slightly different method. Again, the amplitude is the absolute value of negative 6, which is 6. So the period is 2 pi divided by pi over 3, which is 6. So we should know those. No phase shift, so this is 6. No phase shift as before because there's nothing sitting next to that. We cut the period of 6. By the way, the amplitude and the period happen to be the same. We divide by 4, we get 3 halves, and we get those 4 parts. So basically, I'm repeating what we saw in the previous part. So this shouldn't be a big deal yet. At the end points, we're going to evaluate the y for this part. And as you recall, we have those. Okay, y equals minus 6, pi 36. Again, in essence, we are repeating the same thing in the previous part. Okay. And now the next line, because we are moving up by 4 units, these 4 units up, then we write the next ones by adding 4 to each case. So this becomes 4. So keep on adding number 4. 4, negative 2, 4, 10, 4. In other words, You don't have to graph that one, just graph the final result. That's the idea, everybody. If you go on the left side, that means negative 1.5, negative 3, negative 4.5, negative 6, the easy numbers. Okay. For example, just if you plug in negative 1.5, negative 1.5 divided by 3 is negative half, means minus power 2. Sine of minus power 2 is negative 1 times negative 6 is positive 6. Add 4 and you get 10. If you plug in negative 3, cancels out 3, you get minus pi. Sine of minus pi is 0, so 0. Add 4, you get 4, and you can figure out the other two as well. It's very straightforward, everybody. There is really not much to it. Which means you are going to plot the pairs. At 0, you get 4, 1.5, negative 2, and so forth. With y being 4, you can basically think of this as your new x-axis, the midline, if you will, the vertical shift. And so those are the points. Look at those. Remember, they were the x-intercepts for this function, but they have moved up by 4, so they are all of them on this horizontal line, okay, for this function. And you do the other two, you graph it, and now you go. If you want more than one complete period, you have to go to the left and right indefinitely. Again, you don't do that if they ask you for one complete cycle. In this case, I wanted to show you that it continues indefinitely on both sides. I wanted you to be exposed to that. So that's how you graph a function, a sinusoidal. Find the amplitude, period, intercepts, and phase shifts of the function. Sketch the graph of one complete period where y is 2 cosine 3x plus power 2. All right, we start writing the information. To do so, we notice there's number 3 here, and we must take it out for the sake of finding the exact phase shift. So if I factor the 3 out, this becomes x, and this becomes power 2 divided by 3, or power 6. So that's the first thing we should notice. We take out number 3. This becomes x, this becomes power 2 divided by 3, or power 6. So that's important to understand. The amplitude is the absolute value of 2, which is 2. The period 2 pi over omega, whether you go with 2 pi over omega or 2 pi over p, depending upon which one you use, doesn't matter. 2 pi over the coefficient of x, 2 pi over 3. Now, phase shift, there is a phase shift, okay? The phase shift is C over B, and it's negative. This one, therefore, makes it minus pi over 6. The phase shift exists, and it's minus pi over 6. So what do? We cut the period 2 power 3 by 4, and we get 2 pi over 12, 4 times 3. When you divide by a whole number, you multiply it by the denominator, 2 pi over 12 or pi over 6. That is when we cut it into 4 parts. We start with the phase shift. The phase shift is from negative pi over 6, and we add it to the period. So the very first part starts from there. And so we write from minus pi over 6 to 2 pi over 3, and we add this one. In other words, minus pi over 6 plus 2 pi over 3. Please understand this is 4 pi over 6. So I just want to make sure that nobody has any problem that this means 4 pi over 3. 4 pi over 6, which means 3 pi over 6, which means pi over 2. That's how we arrive at pi over 2. Let me write this so it makes it easier for the next part. So understand this is minus pi over 6 to pi over 2, which is 3 pi over 6. That's the meaning of it, okay? So again, 2 pi over 3 means 4 pi over 6, with negative pi over 6 is 3 pi over 6, okay? 3 pi over 6 is pi over 2. So we're going to start to cut this into 4 parts. We're going to go from minus pi over 6 to, now we're going to add just pi over 6, okay? We're going to add this number to this. So minus pi over 6 to 0. 0 to pi over 6. Pi over 6 to 2 pi over 6 or pi over 3. Okay, pi over 3 to 4 pi to 3 pi over 6 or pi over 2. So one more time. We start from minus pi over 6. And we add this amount. We get 0. Now we start from 0 and we add this amount. We get pi over 6. We start from pi over 6 and we add pi over 6. When you add pi over 6, you get 2 pi over 6, which is pi over 3. You start with this and you add another pi over 6. You get 3 pi over 6 or pi over 2. Now, the endpoints, we're going to put it into the original function, this format or this format, doesn't matter. Sometimes one may be easier than the other. For example, if I put minus pi over 6 into this, it makes it easier because this goes away. It becomes 0. What is cosine of 0? 1 times 2 becomes 2. 0, if I put it here, it's easier, becomes pi over 2. What is cosine of pi over 2? 0 times 2 is 0. So this is 0. Pi over 6, if I put it over here, I get 2 pi over 6. 2 pi over 6 times 3 is 6 pi over 6, or simply pi. What is cosine of pi? Negative 1. What is 2 times that? Negative 2. So I've shown you those 3, and I'm going to show you one more by writing it. For example, pi over 3, if I put it here. So pi over 3. Might be easier to put it here. I get 2 cosine of 3 times pi over 3 makes it pi, and pi over 2, 2 cosine of 3 pi over 2. Cosine of 3 pi over 2 is 0. 2 times 0 is 0. So I hope you have no problem evaluating these because those are trigonometric functions you should be familiar. And so we plug in minus pi over 6, 2. Okay, the coordinates, okay, along the x and y axis, the scale may be different. Okay, so roughly over here, we're going to say 2, over here is going to be 1, as long as the y-axis is concerned. And then pi, and cut it into 6 pieces, so minus pi over 6, 0, 0, 0, pi over 6, negative 2, pi over 3, 0, pi over 2, 2, and connect them. That's the cosine function. And you can add more, for example, 2 pi 3, 2 pi over 3, 5 pi over 6 to get what you want. If you want, if you put 2 pi over 3 here, for example, 3 cancel the 3, and you get 2 pi, and pi over 2 becomes really pi over 2. What is cosine of pi over 2? 0 times 2 is 0. So this gives you 0 as an example. You can work on 5 pi over 6. You get negative 2, and you continue indefinitely. This thing continues indefinitely on both sides. Again, just in case. This is one complete cycle, everybody. And if you need to go more on the left and right, you continue indefinitely. Okay. Now, it's important to, write those 0, 0, for example, here. Okay. And pi over 3, 0. So those are the x-intercepts and so on. So it's good to have those and everybody be comfortable with the concept. Okay. Again, one complete cycle. If you want to continue indefinitely, you just move this to the left and right. And again, those 4 sub-intervals or 5 key points are located here: minus pi over 6, 2, 0, 0, pi over 6, negative 2, pi over 3, 0, okay, pi over 2, 2. That's the main complete cycle, taking it from there. So that's how you do cosine. Let's look at tangent. Find the domain and range, intercept, and vertical asymptote of the function. Sketch the graph of the one complete cycle where y is given as tan of 1/2 x. So I want to remind you the way we graph tan x, reminding everyone by definition, tan x is sine over cos. The period for sine, for tangent and cotangent, they both have the period pi, not 2 pi. Vertical asymptote x is 2n plus 1 times pi over 2. Here's the reason. What is the vertical asymptote? When you have a fractional form, you set denominator equal to 0. So I want to show you this. So if you set cosine x is 0, then cosine is 0. Remember, for example, when it's pi over 2 or 3 pi over 2, that means odd multiples of pi over 2. And that's the meaning of 2n plus 1, odd multiples of pi over 2. The x-intercept happens when x-intercept happen when sine is 0. Sine x equal to 0. X equals n pi, as you know. At 0, at pi, at 2 pi, those are 0. So those are easy to see. So when y equals tan of ax or omega x, or however you want to write that, the period would be pi divided by omega. Similar to what we have seen for sine and cosine. Therefore, let me erase my word. In this, and by the way, they don't have amplitude. Remember, that refers to the max and mean somehow. as far as sinusoidal functions are concerned, but the rest of them don't. By that, the rest of the functions, I mean tangent, cotangent, secant, and cosecant. So this pi divided by this number, and again, either we write omega or b depending upon how we wrote that. So divide by 1/2 and you get 2 pi. Now, by the way, as far as the domain of a tangent is concerned, vertical asymptotes, whatever they are, they have to be excluded. So if I'm interested in finding the domain, I pay attention to the vertical asymptote. And the way it works, I want you to understand. For a basic tangent, the period is pi. So pay attention to this to see how easy we can figure this out. The period is pi. So this pi has to be replaced by the period of the function you're working on. The function we are working on, the period is not pi, is 2 pi. So replace this pi with 2 pi, replace this pi with 2 pi for the intercepts and so forth. So the if I replace the pi with 2 pi, let me just show you what happens. I get 2n plus 1 times 2 pi over 2, which makes it 2n plus 1 times pi. So that's my vertical asymptotes. What is the domain? Everything except those. The range doesn't change, it's all real numbers. So domain x can't be 2n plus 1 times pi. Range is all real numbers. Doesn't change anything. And a vertical asymptote, I've already discussed that, those. And for one complete period, the way a basic tangent works, everybody, a basic tangent, you come up with the period, you cut it in half. For the basic tangent, the period is 2 pi, remember that. So this one is x equals minus power 2. This one is x equals power 2. And the graph looks like this. So now you cut this in half, becomes pi. So x equals minus pi and x equals pi. Those are the vertical asymptote. Let me again erase my word. Okay. And then we are going to go with easy points. Minus power 2, 0, and power 2. The reason we are using it because those are easy points. I'm going to start with 0. If you plug in 0, tan of 0 is 0. If you put negative power 2, half of that is negative power 4. Tan of power 4 is positive 1. Tan of negative power 4 is negative 1. So this is negative 1. This is positive. So you get those. And since this is from negative pi and so on, you just plug in. So negative power 2. And this is a different scale or not. This is negative 1. Those are the asymptotes, x equals minus pi and x equals pi. This is 1 point, negative power 2, negative 1, 0, 0, power 2, 1. Putting them together, that would be the graph of the function y equals tan of 1/2 x. We're going to move on. Again, we are given a function. We want to find the amplitude, period, intercepts, and phase shift of the function and sketch the graph y equals 3 cosine pi x minus 4. And again, bear in mind that we are dealing with sinusoidal functions. What does it mean? Sinusoidal functions, the amplitude does exist. When it comes to tangent, cotangent, secant, cosecant, we don't have such a thing, okay? So you want to be careful. Clearly, we do have the amplitude, which is the absolute value of a number sitting in front of cosine. And the absolute value of that is itself. Then the coefficient in front of x is pi. So the period is 2 pi divided by that. 2 pi divided by pi is true. And since nothing else is happening, there is no phase shift. Phase shift? No. And we're going to cut this into 4 parts. Okay. 2 divided by 4 is 1/2. Which means since there is no phase shift, we start from 0 and we go to 1/2. We add 1/2. 0 to 1/2. The next one is 1/2 to add 1/2. 1. 1 to 3 halves, 3 halves to 2. I hope you understand. The reason we start from 0 because there is no phase shift. This one, this is the reason. None means 0. And then we add 1/2. The next one starts with 1/2, with the end point of this one, and you add 1/2. The next one ends with this end point, and so on. So now we are going to plug in, and of course, there's a vertical shift of 4 units down. Okay, just remember that. So there is a vertical shift of d equals 4 units down. Okay, d equals 4 units down. Or y equals -4 in essence. Okay, y equals -4 in essence. So we're going to go with the easy numbers, meaning the end point. So I'm going to start with 0. If I plug in 0 here, what happens? I get cosine of 0. Cosine of 0 is 1. 3 times that is 3. 3 minus 4 is -1. So this is -1. What happens if I put 1/2? Cosine of pi over 2, everybody, is 0 times 3 is 0, so I get -4. If I plug in 1, cosine of pi, -1. 3 times that, -3 and -4 is -7. You can figure out the rest. I'm going to show you what happens if I use, for example, 3/2. Let me just work it out again. So I was doing it in my head. I want to show you that basically you say y plus 3 cosine. Remember, we're going to go with 3/2, so I'm going to replace the x with 3/2 minus. So cosine of 3/2 pi is 0, so the answer is negative. Okay. If I put 2, I get 2 pi. Cosine of 2 pi over 0 is 1 times 3 is 3. 3 minus 4 becomes negative. That's how we get that, everybody. Okay. Very simple. You plug in. Let me erase my work again. Because again, this means 4 units down. D, 4 units down means y equals -4 is the midline. Let me erase my work. So zero, -1, and fast, this is the axis, okay? 0, -1 is somewhere here. 1 minus 7, this is minus 8. So somewhere here, okay. 2, negative 1. I'm using this as 1, so that means uh, over here we get 2, negative 1, okay, 2, negative 1. I'm using 2 of them to represent 1, okay, everybody. So 4 of them represent 2. 1/2, that means somewhere here, okay. And what? Negative 4. So right here, because this is y equals negative 4. And then 3/2 is also negative 4 somewhere there. Here's the graph. Okay. And again, this is one complete cycle. You can continue indefinitely on both sides if it just says graph it. If they don't say one complete cycle, then you have to continue indefinitely on both sides. Now, we are going to do the same thing in the information that we have for y equals cosecant pi x. For now, I want to ignore that, and I want to show you how this thing works in general first, and then we get to that one. First, just ignore that. You know cosecant is the reciprocal of sine, right? So graph sine. Graph y equals sine pi x. I'm going to come back to this. Since cosecant is 1 over sine, just ignore it and graph y equals sine x. And you know that the amplitude is 1. The period is 2 pi divided by pi makes it 2. Nothing is happening. There is no phase shift. Cut the period into 4, you get 1/2. And we go from 0, since there's no phase shift, we go from 0 to 1/2, and we keep on adding 1/2. So 0 to 1/2, then we start with 1/2, add 1/2, 1, 1, comma 3/2, 3/2, 2. And now you plug in into sine. If I plug in 0, I get 0. So those are the end points, 1, 0, 1/2, 1, 3/2, 2. If I plug in 0, I get sine of 0. If I put 1/2, sine of pi over 2, 1. Okay. If I put 1, sine of pi is 0. If I put 3/2, sine of 3/2 is negative 1. If I put 2, sine of 2 pi is 0. And those are easy graphs. Plot those 3 points, the x-intercepts, and then the other 2 points. That's your sine. Now, as far as graphing the sine is concerned, is easy. So how do you graph cosecant? Flip this over. That means go up like that, go up like that, down like that. So flip over the graph, looking like that. And it continues indefinitely. Again, if you want one complete cycle, you're done. Otherwise, you continue with the sine and you continue with the cosecant. Now, here's the information I want you to notice. Because it's 1 over sine x, then if you set sine x equal to 0, x becomes n pi, and that becomes your vertical asymptote, and x can't be n pi becomes your domain. Range, the sine covers from -1 to 1, so its reciprocal can't have those. That's why you put the range is -infinity to -1 union 1 to infinity in general. And it's an odd function just like sine, because sine is odd, so is cosecant. Now the period is 2 pi. Therefore, for the domain, you got to change this pi to the period divided by 2, okay? So that's as far as the domain is concerned. So if you replace the period over here, the period is 2, and over here you use half of that, half of this number is 1. So again, pi, when the period is 2 pi, you use half of it here. You put pi. When the period is 2, you use half of it here. So the domain x can't be n, and vertical asymptote x equals n. So that's the domain. The range remains the same. Negative infinity to negative 1 union 1 to infinity, negative 1 and 1 both, they take brackets, they are included. As I said, vertical asymptote x equals n. For us, x equals 0, 1, 2 for one complete cycle. So we have those three. X equals 0, x equals 1, x equals 2. All right, now in this case, we want to find the equation. So in order to come up with the equation, we have to pay attention to a few important parts. Why don't we just put those parts, the intercepts, the max and mean. So we have 0, 0 here, 2, 0, 4, 0. We have 1, negative 1 half, 3, comma 2. So those are the ones that we have. So definitely this is a sine function. Looks like a sine function, in fact, that has been inverted. So a sine omega x. And there is no phase shift. Why not? Because it starts from 0, 0. So what is the amplitude? You see this distance is 2, so is this distance. So clearly, absolute value of negative 2, I have to say it has flipped over, which makes it 2. In other words, note that this is reflection over the x-axis. So the basic sign, remember the sign is that normally class. Yeah, looks like that. Okay, y sine. So that's why it's a reflection with respect to the x-axis. So because of that, a must be negative 2, therefore. And as far as the period is concerned, which has the equation 2 pi over omega, is this distance, everybody. This is the period from here to here. That means t is 4. T is 4, and t has the formula 2 pi over omega, which means omega for omega must be 2 pi. Omega must be pi over 2. Therefore, y, which is a sine omega x, equals negative 2 sine pi over 2 times x. So very straightforward, everybody. We want to write an equation of a sine function given the information as follows. Amplitude is given, t is given, and phi over omega is negative 1/3. So omega is 2 pi over t. This is the general form. Again, there are two formats. This is one format to write it, and we are going to fill up everything. So we start with omega, which is 2 pi over t. So replace the t with 3 pi, and that gives you 2/3. And we are going to plug in. We got everything, believe it or not. A, we have it, is 3. Omega, we have it, 2/3. Minus pi over omega, we have it, minus negative 1/3, which makes it positive 1/3. And if we distribute the 2/3, this becomes 2/3 x, this becomes 2/9, and we are done. We don't have anything about B, it's not given, it doesn't exist, and we are done with that. We'll get the last question. The information is given. Draw a scatter plot and find a sinusoidal function of the form y equals a sine omega x minus 5 plus b that fits the monthly temperature data for Indianapolis. So we want to find some sort of a sinusoidal functions that can fit the data. So you plot the pairs, okay? Number 1, 28.1. Number 2, 32.1. Number 3, 42.2. Those are the pairs. So 1, 28.1, 2, 32.1, and you do all of it. A is maximum minus minimum divided by 2. I hope you remember for a sinusoidal function. Let me just draw that and remind you what I mean by that. If you look at the basic sine function, it's A. This is A. So maximum minus minimum divided by 2. That's how you find it. Maximum minus minimum divided by 2. Remember, the maximum is 1, the minimum is negative 1, 1 minus 1 is positive 2 divided by 2 for a basic function. Remember, the amplitude is 1. In any event, A is 1. And so max minus mean. So we need to locate the maximum and the minimum. So the maximum and minimum have the following values. January 1st, 28.1, or January just 1, okay? January 1st, we're going to go with 1. So 128.1, that's the minimum, that's the maximum. So basically 75.4 minus 28.1 divided by 2. That would be the first one. You do the math, you get 47.3 divided by 2 is 23.65. Let me erase my work, everybody. What is the vertical shift? B is max plus mean divided by 2. If you go back to what I had, when we add them up, 1 and negative 1, we get 0 divided by 2, right? So now add them up and divide by 2. You get 103.5 divided by 2, or 51.75. T is 2 pi over omega, and the period we're talking about a yearly event, we're talking about 12 months. January, February, all the way to December. So I hope you recognize that we are using 12 months, right? Monthly temperature in a year. So we're going to divide 2 pi by 12, gives us pi over 6. So here's the sinusoidal function. The period is normally 2 pi. Now it's 12, so 2 pi corresponds to 12. This is 0, this is 6. Again, the basic one, and then what we have. So t is 12, and if we cut it in 4, becomes 3. So why are we cutting it in 4? The maximum occurs for a basic one. Okay, look at the very first arc that we did. We had to cut it into 4. The third, in this case, the third one. So the x coordinate of the max value, which is July, it is supposed to be 7 instead of 3. July 7, but it should be 3, right? If it was a sinusoidal function with no phase shift. No phase shift should have been 3. But there is a phase shift, and it's gone to the right by 7 minus 3 or 4 units. We are ready to plug in all the values. So the function is a sine of omega, parentheses x minus 5 over omega plus b, and we just plug in everything that we have. Let's start with a, 23.65. Then omega, remember, omega is pi over 6. So we're going to replace this with pi over 6. And then x, we're looking at this one. X minus 5 over omega, x minus 4. And then plus 51.75. Now I can put the pi over 6 in because I want to put it in this format. So this becomes pi over 6 times x, and I multiply it by this, I get minus 4 pi over 6. Minus 4 pi over 6 is minus 2 pi over 3. And that's the final answer, everybody.